Today we are going to discuss one developed step of CRD. This is about randomized completed block design. So today we are adding some blocks into our traditional CRD complete randomized design. We are adding some concepts of block into the CRD. So especially we call it as randomized complete block design. In short term, we can say it as RCBD. So you should remember what the short forms are standing for. Yeah, when I am giving a description about this model, probably the most used and useful of experimental design. So most probably we are considering at least two factors which are explaining the variation of our dependent variable. Last time we discussed a one component explaining the variability of our response variable. So in this step, we are developing our explainable variation part into two factors. So traditionally we called that factor in our first CRD model as treatment. Here we are considering the treatment as the block. That's why I told you that time also, sometime we are referring to the term of treatment for different aspects. So here we are using the term treatment to represent our effect of blocks. Then there are some replications for those blocks also, but the randomness, I think you will remember that we are considering the randomness, but here we are keeping that randomization quality by using the replications. You will realize what I told when you are coming to next 3-4 slides. Okay, the second point takes advantage of grouping similar experiment unit into block of replicates. Then what is the logic of taking that blocks? We are grouping similar experimental units. We take blocks for similar experimental units or replicates. Then you can apply that concept of blocking for the similar cases, whatever that was treatment or replicate. The blocks of experimental units should be as uniform as possible. So under the blocks, each experimental unit should be uniform as much as possible. The purpose of grouping experimental units is to have the units in a block as uniform as possible so that the observed differences between treatments will be larger due to true difference between treatments. So we are taking uniform into our blocks, uniform observations into our blocks, but in between these blocks, there may be large differences. So that is the true differences between treatments. So as I mentioned you earlier, we are considering our blocks as treatments. So there are differences, huge differences in between treatments, but inside of a treatment, those observations should be uniform. So that is the quality, or that is the logic of taking blocks into a design. So with the adaptation of blocks, the model has been turned into randomized complete block design. So the calculations are moderated according to those adjustments. Then the randomization procedure. So this is one of an advanced assumption in the design. So we need to protect the randomization procedure in our each experimental design case. Each replicate is randomized separately. Each treatment has the same probability of being assigned to a given experimental unit within a replicate. each treatment must appear at least once per replicate. So now with the RCBD model, we have to deal with treatments and the replications. So we need to protect the randomization with respect to the replicates. So each treatment must appear at least once per replicate. So each treatment have at least one observation. So that observation should be a randomized observation. That's the thing in this slide. So you can read the handout leisurely again. I'm moving for the next slide. Assume mu is a baseline mean. So we have already discussed that part. You already know that. What mean by that mu? We can consider it as the baseline mean. Tau I is the I treatment effect. So we are using tau here to represent the treatment effect. Then beta j. Beta j is the jth block effect. So we have estimated block effect around the beta notation. And EIJ is the random error of observation. So this is the model for the RCBD. As I stated you very early of our lecture series, we need to model what we are going to estimate. So that is the first image, the reference part. Suppose you are conducting this kind of a model for your exam. This is the first step. I am understanding whether you have identified the model very correctly or not. So in advance, I think you have already learned distribution theory. We can denoted that our excited, this is one of our assumptions in most of our inferential statistical technique. We are making some assumptions around our error term. So here it is independent, identically distributed, and normally distributed. Independent, identical, and normally distributed. So what are the parameters of normal distribution? What are the parameters of normal distribution? Yes, mean and the mean and the variance. So those two are within the brackets. So you can write these assumptions also with your model, then that will sound enough statistically. Then mu, it's okay. Tau I, it's so you should mention how many observations for the I, and beta j, you need to represent what is the scope of j or not uniquely estimate. Constraints must be imposed. So I will taught you what mean by constraints later. To be able to calculate estimate mu hat, tau I hat, and beta j hat, we need to estimate those things. We need to impose two constraints. So I will discuss constraint with the compounding chapter later. So this is an example. So what you can identify by seeing this one. It is about given for fertilizer rate applied for amidon wheat, which means the Thiringupiti, and 3 replication of each treatment. So what they have done, they have cultivated wheat, then they have used 3 fertilizer. Now what they are going to do, now they are going to test the effect of fertilizer. That's their objective in this treatment. They are going to test what is the most effective fertilizer for wheat. So that is the replication 1 and replication 2 and replication 3 representing our replicates. Then fertilizer. How many fertilizers? There are 4. Okay. Then A, B, C, D representing our 4 fertilizers. So what mean by the A? Sorry, they are not using 4 fertilizers. They are using 4 rates of fertilizer. They are using the same fertilizer, but there are 4 rates. For 4 fertilizer rates they have applied. So these are the rates. I don't know what's the real mean of this N divided by HA. That is a notification, scientific notification for the fertilizer. Anyway, we can assume that that's about a fertilizer they used. So for the eighth process, what they have done, they haven't used any fertilizer. So that's their control. Then I think we have explained what mean by the control very well. So if you have questions about what mean by that, you can raise your hands and you can ask any question. But what is the meaning here? It's about no fertilizer because they didn't add any fertilizer under that one because the value is 0. Then for the Bth one, they have added 50 kilograms. So they have added 50 kilograms for their cultivation, for their grounds. And under the C, they have added 100 kilograms of fertilizer. That is the experiment they have done under the C. And under the D, they have used 150 kilograms of fertilizer. So that's their another rate of fertilizer used for their cultivation. So you can identify these 4 figures they have used as the blocks. Because they have used same amount. They have maintained the similarity in between all replications for the same block. So if you take A, they didn't use any fertilizer for the any treatment. So under each treatment for the block A, they didn't use anyone. So for the B, for each replication, they have used 50 kilograms. So that's similar in 3 replications. For C, they have used 100 kilograms of fertilizer. That is similar for 3 replications. And D, also similar. They have used similar things. So now you can realize for a block, we need to maintain the similarity in between each replications. Okay, then what are the advantages of CRD? Generally more precise than CRD. The block design have increased the precision of the model than the CRD. No restriction on the number of treatment of replicates. Then we haven't any restriction for number of treatments or the replications. Some treatments may be replicated more time than others. Some treatments may be replicated more times than others. Missing plots are easily estimated. So there may be some cases of missing values. So we faced for a power cut. I don't know whether I will disconnect from the Zoom or not, because with the power cut, our internet connection also getting disconnect. So can you still hear me? Okay, the 5th point is all treatments or enter replicates may be. Okay, we were discussing about the advantages of CRBD. So I think I don't know whether you could hear these things or not. Then you can read this leisurely. And I was talking to you about the 5th point. Whole treatment or entire applications may be deleted from the analysis. And if experimental error is heterogeneous, valid comparisons can still be made. So these are the advantages of CRBD model than the CRD. Then you can read these things leisurely and ask any question next day if you have any question. Okay, what mean by the precision? I think you are well aware about the biasness and the precision because you have already completed the sampling technique problem. So what mean by the biasness and what mean by the precision? So if I put some letters, can you tell me what is the most unbiased thing and what is the most precise things? Okay, then this is C and D. Then can you text me through the chat box what are the most precise image? What are the most precise image? Okay, hurry up. Don't take too much time. And you need to identify what are the most unbiased image. Still, I didn't receive any answer. You need to identify. Then, at least if you read what it says in the image, you can identify. Then, image A is inaccurate, unbiased, but imprecise. It's not a precise image. Then, what's the B? It's accurate, it's unbiased, and it's precise. So, this is the best option. B is the best option. Then C, it's inaccurate, it's biased, and it's imprecise. Then D, it's inaccurate, it's biased, but it's precise. So what mean by the precise? We are gathered around the point. That means by the precision. Then the biasness, we are taking some wrong direction. So you already well know about what mean by the biasness. So you can see the all informations in the image D have gathered around the point, but it's in somewhat wrong direction. So the place is somewhat different. So this is the B is the best option. So you need to identify what is the biasness and precision in statistical models. So we can precise more using more information about the variability of our response variable. That's why RCBD is somewhat advanced than the CRD. Okay, then what are the disadvantages of RCBD? This is not the best model because we can learn more and more models through this course. So this is one option, something better than the CRD, but this also still have some disadvantages. So what are those? Error degrees of freedom is smaller than that for the CRD. Problem with the small number of treatments. So when we are taking more fraction about the explainable variation, we are having a more amount of degrees of freedom for that part from those parts. So from the total, we are reducing those parts in the degrees of freedom. So the error degrees of freedom will be smaller and smaller. If there is a large variation between experimental units within a block, a large error term may result. So if there is a large variation between experimental units within blocks, a larger error term may result. So we need to avoid those kind of errors from our models. If there are missing data, a CRBD experiment may be less efficient than CRD. So this is good for the complete design. That's why the term is randomized complete block design. I have already introduced you what I mean by the complete and incomplete models. So this is less efficient for the incomplete design. So in the all the time we should have some balanced type. So we assume that this model is more efficient for the complete design than the incomplete. So for the incomplete cases, CRD is somewhat efficient than the RCBD. So the most important term to consider when choosing a design is the uniformity of the experimental routine. So when you are considering the CRBD, the uniformity is the most important character you should consider. So this is the important term you should consider when you are selecting this kind of a model for your problems. Okay, now you are having an example. So take few minutes and take these observations into your notes. So we can make some calculations. Okay, take few minutes and take these observations into your note. Okay, you can obtain these equations also. Then finally, I will show the results. The first step 1, calculate the correction factor. So this is the equation we have used very early also. Anyway, you can take it again into your notes. So the step 2, calculate the total sum of square. So that procedure was pretty similar for the previous one. Anyway, you can take that also into your note. Okay, what's the step 3? Calculate the replicate sum of square. So you need to take the summation along ith observation, ith notation, and you need to take the square value of that one and divide it by a number of observations under that. So calculate the treatment sum of square. Then last time we conducted one part, only one term. Here we are taking treatment sum of square and replicate sum of square, both things. So when you take the replicate sum of square, you need to divide it by the amount of treatments. When you take the treatment sum of square, you need to divide the you need to take the summation along the treatments, and you need to divide it by the, you need to take the square value of that one, and finally you should divide it by the amount of replications for each treatment. So here we are having the complete design. So this amount will be same for each one. Finally, you can reduce correction factor from that. And the fifth point is calculate the sum of square of error. At that place, you need to reduce replicate sum of square and treatment sum of square, both cases, from the total sum of square. Okay, this is the ANOVA table we should create. So you can identify we have increased our source of variances, which are the explainable variation part. So replicate sum of square, treatment sum of square have come in here. Then for the replications, you can reduce one from the amount of replications. For the degrees of freedom for the treatment, you can reduce one from the amount of treatments. And for the total, you can multiply the amount of treatment and replicates and minus 1. So finally, you can use this way to find the degrees of freedom for the error. So these are the ways, and you will have two test statistics with respect to the treatment and with respect to the replication. So in that case, you can say whether there is any treatment effect for the variation of the response variable and whether there is any replication effect for the variation of our response variable. So you need to construct hypotheses separately for replication and treatment. So with respect to those, finally you need to state your test statistic and your decision rule for treatment and replications, and you need to draw the conclusion for replication and treatment separately. Okay, that's the thing we have discussed today. Anyway, then we can enter for the mean comparison procedure. Still we did not discuss anything about the mean comparison procedure. Then that's due to the if you have rejected the null hypothesis and if you have taken the alternative one, then we need to find what's the different group. Then what is the affected group, whether there may be some similar groups inside of our treatments or replications. Then we need to find what is the different one, or there may be more than one different group. So we need to find what is the different one. So we are entering for that step next. Now we can complete this one. So please start to solve this problem. You can maximally take, now this time is 10. Maximally you can take time until 10:30. I will be in the Zoom platform. You can be Zoom or you can left Zoom and you can join again 10:30 with your answers or the problems you have. Okay, let's start to make these calculations. I will pause recording and I will start again recording when we are entering for our discussion part. Okay, let's start.